All right, so problem 3 is talking about runners on a team. It gives their traditional mean and standard deviation. And the first question is not about the team, it's just about runner 3. Runner 3 thinks he can run a mile in less than 4.2 minutes in the next race. Is this likely to happen? All right, so based on what we know his mean is 4.5 with a standard deviation of 0.14. So how can we figure out the probability that it's less than 4.2? Do what? Normal CDF. All right? Because we're assuming that there's a normal distribution and that his center is 4.5. So if we know where 4.2 is, then we're finding that. Okay, so we'll go to normal CDF in the calculator. I'd probably put in a lower of 0, an upper of 4.2, and then they gave us the mean. The mean is 4.5, and the standard deviation is 0.14. 0.02275. So is this likely to happen?
No.
It is not very likely.
So 2% chance.
So it's in 2 places. You can the easiest way is probably statistics. So you'll go menu, statistics, number 5, distribution, and then it's the number 2 one on the list there. So it becomes menu 652.
Wait, 1, 4?
So like, isn't the closer the number is to 1, the more likely it is?
Yes.
I mean, sorry.
So this is a probability. So it'll be between 0 and 1.
Okay.
Mm-hmm. Yeah, Abby.
Is it 0.14 or 0.15?
It's runner 3, so it's 0.14.
Wait, how did you get?
How do you get what? Okay. All right, let's go ahead and go into the next part. B says the distribution of possible team times is approximately normal. What are the mean and standard deviation of this distribution? So even though this question's on B on the next page, I'm going to come back to A to answer that. Yeah. Sure.
Yeah, I used the wrong standard deviation. I heard 0.15.
Okay. So what should it be instead?
0.016062.
0.16?
Yeah.
All right, now are we in agreement? All right, everyone's typing in different numbers. There's a lot of that on the take-home test.
No, it's a take-home test.
Wait, is
guys.
that
Come
one
on.
of the tests that you put in?
Huh?
I was confused.
Yeah, it's one of them. Okay. But looking through some of your work, this is why it was so important that I told you not just to tell me an answer, because sometimes people would type just a little different, and it would give you a completely different answer. Or maybe you wrote down all the right information and then you put it in the calculator wrong. And so it becomes very important that you write down the right information so I know that you know what's going on. Okay, what we want to look at now is the total team time. If they ran it like a relay and they were doing these times together, and assuming we don't have to worry about transitions, how would we add all their times together? So means is the easy one. We just add all the means. So what is 4.9 plus 4.7 plus 4.8, 4.5 plus 4.8? 0.9? 18.9. Okay, so that would be the total for all of them. All right, standard deviation not as easy. That we need to do another step. We can't add standard deviations.
You have to do the squared or
We always add the variance.
variance.
And the variance is the standard deviation squared. So what's 0.15 squared?
Let me do that.
0.0225. We're just squaring each standard deviation. These we can add. Variances you always add, even if you're looking at differences. But in this case, we're looking for the sum. So what do you get when you add all 4 of these together?
A number.
What'd you get, Jorge?
0.09.
0.0902. And then take the square root of that to get the team standard deviation.
0.3003.
Okay. So we can round that and say about 0.3 minutes here out of 18.9 minutes for the team total time.
Wait, this is what we discovered.
Sure. Let me write this and then I'll come answer your question.
I thought it was 0.3.
All right, what's the question?
The square root of the sum of the variances.
Yeah. It was 0.3003. All right, part C, suppose the team's best time to date is 18.4 minutes. What's the probability the team will beat its own best time in the next race? This, we're just going to do a normal CDF based on the mean and standard deviation before. For time's sake, well, no, that's the last one on this part. We'll go ahead and do it. So, again, we're doing normal CDF. This time, we're looking at their total time, so it's a different distribution, but still normal. 18.9 with a standard deviation of 0.3. And so we want to know what's the chance they beat 18.4. Remember, beat would be to be faster than it. So your lower this time would be 0 again. Your upper, 18.4. But then using the mean we got in the problem above, and the standard deviation. You can calculate a probability. Let me go and say this now, that on my test and the AP test, what if you got to a problem like D, which is asking for your answer on C, and you didn't get the answer on C? You have no idea how to do C. Please, please, please still find a way to do, I'm saying the parts numbered on, B and C. But if you didn't know how to do B, make up answers for B. All right? Even for me and the AP graders say, my imaginary answer for B is this. So based on that answer, my answer for C is this. I will do the math. I will take time to calculate, and the AP graders will do the same thing. They always want to test each part individually. So if you're not sure, make up an answer to a previous part just so you can answer the next part. All right. What'd y'all get for this one? 0.0. Okay, 5 when you round it. Okay, in this case, they're just asking what's the probability. Is it likely?
No.
Not very, but it's possible. Great.
0.5.